So our focus today will be on Apache Spark, which is a DataFrame. And so our learning outcome is to, learn Spark DataFrame with Python, and also to understand how and when to apply different methods of creating DataFrame, to understand how and when to apply functions in solving data-related problems. And also for us to have hands-on experience on data transformation using DataFrame. So that's our focus today. And let me explain DataFrame itself. A DataFrame, before I start with a DataFrame, in Spark, Apache Spark, we've got RDD and we have DataFrame. They both have Python API. DataFrame is an improved version of RDD. Sometimes a lot of people working on Spark, some are used to RDD, but there's some limitation in RDD because RDD works on rows, row-based, while DataFrame can actually process data on rows and also on column-based. So is an RDD, DataFrame is an improved, is an improvement on RDD. So looking at those shortcomings, those things that RDD cannot do, which is a Spark, then DataFrame can undo that. So DataFrame is a distributed collection of organized data into named columns. So it can be constructed from different sources like, such as structured data file, tables in Hive, external databases, or existing RDDs. So structured data, we all understand what structured data is. I give an example, like structured data is data that have been transformed, like it's been cleaned, all the duplicate has been dropped. Like for example, all those data that has been completely, joined together, all those stuff, and they are all completely, transformed. So we have tables in Hive. Hive is a form of a database, like where you can create table, you can, use inner join and the rest. It's like SQL related query. And external databases like RDS, relational databases, MySQL, Oracle, and the rest. Then our existing RDDs. DataFrame is a programming language in Apache Spark. Just like we have our SQL, you've seen how we use SQL to transform data, how we're doing inner join and doing some other things in the SQL. The same thing applies to DataFrame. All programming languages, they are completely related, but they have some other things they do. So DataFrame is a programming language only. So it's an Apache Spark. It's like a module in Apache Spark. So we have RDD also, and they do the same thing. I will give you an example. Let me go to, before I continue, before we start, let's go to the website of Apache. You see the details of what I'm talking about. So when we go further, you will understand better. 1 second. Good. Now, so you see, Apache Spark is a multi-language engine for executing data engineering, data science, and machine learning on single node machine or clusters. Can you see how it works? Now, let me explain a few things about Apache Spark. Apache Spark is in-memory based. That means it helps you to process your data faster. Like we've got, the old package, which is the Hadoop. Hadoop works on the hard disk. So thereby there is a limitation to the way it can process data. But Apache Spark runs on memory. So because it can remember whatever has been processed and it can recollect it back without being affected, without affecting the performance. So Apache Spark does that. And in Apache Spark, we have DataFrame and we have RDD. So RDD, just like I said the other time, is just like a way of a programming language being used to transform data. And what makes RDD and DataFrame to be unique is that it can work on distributed data. It can process data in a distributed way. For example, you have 10,000 gigabytes of data or maybe 1 petabyte of data. That's a very large data. Apache Spark will look at this data and it will assign it like, okay, let's say as a manager, I've got some tasks to do. I need to assign it to workers, co-workers, maybe some staffs that are working under me. The Apache Spark, one of the cluster manager, will look at other nodes and assign those tasks to them so that it can be done quickly within seconds. Remember in the first class, I think first class, I was explaining laborer. If you could remember, I was explaining laborer and I talked about if one person can do a particular work in 5 hours. What about if 5 people, if they do it, that means they finish it within 1 hour because it's being distributed equally. And that is what Apache Spark is doing. It helps you to process your data faster. And in Apache Spark, we've got streaming. You've got parse streaming, where you process data, you stream data in real time. In real time. Real time means, for example, we have weather data. Weather data, you want to know what is going to be the next temperature in the next 5 seconds. Maybe temperature is going to change. Maybe it's going to be 5 degrees now. In the next 5 seconds, it's going to be 6 degrees. Spark streaming as a module in Apache Spark helps you to get this data in real time. And also in this Spark, we've got Spark SQL, similar to the SQL that we're doing, completely similar. So you've got the experience of SQL, so you can work on Spark SQL using your knowledge of SQL. And we have machine learning and the rest. But let's go back to this, then I will explain better as we go on. So now, DataFrame itself is a Spark on its own, but in Apache Spark, we have DataFrame and we have RDDs. It's a programming language on its own, but uses Python API. And we've got under the same as Apache Spark, we've got R. If you can see here, I showed R. You see here, we've got Python. Can you see Python? Can you see SQL? We have Scala, and we have Java, and we have R. So like if you have some experience in R and you want to focus on R API, that's in Spark, you can continue with this. Or you have strong experience in Java, you can work on this, Scala, and this. But most popular library that we have is Python and Scala, including SQL. So, and some companies use Java also. So that's the aspect of Spark. But while we continue, you understand what we mean by Spark and how we can apply it. So, like I said DataFrame can be constructed from different sources such as structured data files. We already have understanding of structured data file, like our files that is well structured. Let's say, for example, look at this data is well structured. That's no duplicates in this data, and it's well structured. You see, there is no, let's say, null values or whatever, and everything is clean. It's like a structured data. But in terms of unstructured data could be in form of data coming from API in JSON formats. And this RDD can be used to handle files in CSV file. You can use it to work on Excel file. You can use it to transform data in JSON format, or even in XML. So these are the things you can use DataFrame to do, Apache Spark. Now, for us to create DataFrame, we can create DataFrame by using toDF. So df, can you see the sign, and create DataFrame. So to create this DataFrame, we can as well use, let's say, for example, we can create like a column. For example, what I mean by columns here is, let me show you an example here. Just like this. You have, 1 second, please. We have this. This is a column name. We have LA_name, LA_code, this. But instead of creating this in our data, as in getting it from our data, we are just creating it manually here. Column equals to LA_code. Can you see? Similar to what we already have here. Can you see? LA_code, middle age. So we manually creating that, and then we now passing our data. The data is what we have here now. This is the data. This is the values. These are the values of this particular column. This is the key. This is the key. These are the values. So we have the values here. So here, instead of using file, I'm just trying to ensure that I show you the values here. Can you see? This LA_code has got LA_code has got value of E006-005 as the first row, middle age 20917 as the first row, and this one second row, and this is the third row. So to do that, in Apache Spark, there is a library called Spark section. For you to load Apache Spark, to work on Apache Spark, you need to use Spark section.builder. So I would say is part of the module of Spark section. Please don't I will try and break this particular part down. You know, like we talk about Spark, this is a variable name on its own, but this Spark section is a function from Spark module. This Spark section is a function. It's not just a name. It's just like you are doing join. Join is a function in SQL. Inner join is a function in SQL. Select is a function. Select is to select a particular column. You know, when you want to join, you use inner join, left join, and they are all functions that are doing one thing or the other. The same thing applies to this one. This Spark section helps you to access all the modules in Spark. Spark section.builder.app name. Then you give the name of your app, any name. I can decide to give this app name as Okpe Data Engineer, and put this double inverted comma dot get.
So you've been calling my name too much in this class. You pay me, sir.
Yes, I have a reason just to make sure that I explain. Yes, don't worry, we'll talk about that. So, you know, this particular part is just for you to have understanding about why do we use big data section here. So you can use your app name, you can use any name. I can decide to say Damilola data section, Bola data section. So it's a name for your app. Then you do dot get.
It's just like giving it the name for the file. So
no, it's not the name. It's not the name of the file. It's the name of the app for you to run, to identify that, okay, this Spark section has got a name that is going to run on. Then this name will not be repeated, is unique to it. When we go on, you will understand what I'm trying to explain. So now we have get or create. Then you do get or create. And there is something about Spark for us to run this particular Spark section. We have to access the module. We have to access the module. We have to access the module. And the module is from PySpark. Let me see if I have it here. I think I didn't document it separately. 1 second. Yes, no, it's not here. Let me just, should have written it here as part of the document here. 1 second, please. Give me 1 second. I've got simple here. Before we start using our ID, let me use some sample here. Please don't mind this one. Just gonna use it for illustration so that you can see what I'm trying to explain. Okay, good. I think I have this. Good. So forget about what we have there. So this is what I'm trying to explain. We have from PySpark, we want to access this Spark module now. We do from PySpark .sql import Spark section. We are trying to get Spark section from the PySpark module that we have. This Spark section is what we are passing here as a function. So it's doing something. So it's a function that is doing part of the module that is doing something. Spark section dot builder dot. So inside this Spark section, you can access builder, which is another function, and you can access this app name. 1 second, please. App name. And here you see my app name, I put data learning. And I did dot create a get, or look at this, or it's got capital, then we have lowercase, create this. Then we'll be able to access this Spark. You know, I was showing you this example, column LA middle H from here. If you see, I was showing you this. We said column equals to LA this. So this is, here we are trying to create a column for a particular data. We are trying to like add coding. We are add coding the values now. We're not getting it from CSV file. So we have our data as EO this, 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 and this is our data. And what I'm trying to explain here is that for us to create data frame, we use toDF. Look at this two. D, capital D, that's uppercase, F uppercase, and this is a function. This is doing something. And we have, or we can use create data frame. Create data frame. Look at this, create data frame. So these are the ways we can create our data frame. So while we go on, we have our columns, the column name, just like we have in our Excel file. I'm trying to connect you to how this is related to Excel. Can you see LA underscore code middle H? But in this case, I'm add coding the value. So that's where we have that. We have LA underscore code middle A underscore H, and these are the values that we have for each rows. So now,
sir, can I ask a question? When you said I'm add coding the values, that means that you are the one creating the value, right?
Yes, I'm creating the value. Yes.
So it's different. That's different from when the data already exists somewhere and you're bringing it into the data frame.
Thank you so much. You got it. You're right. So now we continue from here. Can you see? I've shown you the example here. I have Spark equals to Spark section builder.app name. And I said this. And here, I now used the Spark here. So I will go further here by explaining what I did here. Now, after calling this Spark section, there is part of Spark section where you can explore some libraries that is related to RDD. So like I said the other time, I said RDD DataFrame is an improved version of what? Of Spark. So it's an improved version of Spark. And what is RDD? RDD is resilient distributed data sets. That is RDD. So the data frame is an improved version of Spark where you can, access some things. You can even convert from the RDD to data frame, work on from RDD, from that data frame, you can convert to Spark SQL. From Spark SQL, you can also access like Pandas data frame. You can work around using this Spark. So Spark is a bit dynamic. You can use it to do lots of things. accessing database, creating tables and stuff. So now in this case, what we are trying to do, sorry about that. So what we're trying to do here is to access some of the RDD modules. You know, I said the other time, if you go back here, I said DataFrame can be constructed from different sources such as structured data files, tables in Hive. Hive is like SQL. You create database and tables, external databases or existing RDDs. So we want to focus on our existing RDDs now. So in our existing RDD, for you to access RDD, you use spark.sparkContest.parallelize. And this is the data. Look at the data that we have here. Data, we pass in this data here now. We pass it inside here. And this is how to access the RDD, how to run your RDD. Spark.sparkContest.parallelize data. Now, we want to now convert this our RDD now. Look at this. We have spark.sparkContest is the library, and inside sparkContest, we have parallelize. We access parallelize to load this our data. So in reality, if you want to access file in RDD, you can get this particular file now. For example, UK data, and get the part of the file where the file is coming from and put it as, you know, the directory part, the part of the file. Now you'll be able to load this data in RDD. So now, to go further, we can use TODF. Like I said, if you want to create DataFrame, you use TODF or create DataFrame. I've mentioned it here, TODF and create DataFrame. So I've shown the example of where we are creating our RDD, but we want to convert this our RDD to DataFrame now. So we now use a variable name. We have RDD_2_df. This can be any name. I can do Okpe. Okpe, I'm using your name again. Okpe_2_df. So it can be any name. Damilola _2_df, Jerry_2_df. So I can use any name. So I'm passing this RDD. Can you see this RDD? I'm putting it here. Then do .TODF colon. Then we can now display result from the data frame. Let's say an example here. Let me run this one. This is Google Colab. Is a platform where you can also run your code. You know, it's for research purposes. Some of you are familiar with Google Colab. So I will run this one. I will just quickly run it. So if you need access to this one, apart from our normal PyCharm, you can also use this one. But this is just for, it's doing the same thing that we're doing here. So I'm going to run this one quickly, so we start exploring a few things. So 1 second. Spark.
Sir, if you are going to do this within the work environment, are we going to be doing it on the Amazon AWS? Or is it a different environment where we are going to be able to do it?
Okay, let me explain how it works. You'll be doing it in this environment.
On Google Colab?
No, not on Google Colab, on PyCharm. We're still going to come back to this PyCharm. We're going to be doing that here. Are you getting me? Okay, let me just start using it. Let me first show you this one because I just want to show some values. You know, remember I explained in that material we have from PySpark.sql import Spark section. So we want to import this library and we're going to run Spark. So I can decide to say Okpe_Spark equals to the Spark section that we're importing here, which is this dot. So inside this Spark section, we have builder. We're going to explore that module builder. Then we have app name. We're giving our app a name. So I'll do Okpe_data_lining dot get or create. So this is a function that we are also accessing. So this is what is going to run our Spark. So we are calling, let me use this one Spark. I don't want to use Okpe here. So now let's run this one now. When we run it, then let's go further. We've gotten an environment Spark ready now. So it's loading. Can you see? Can you see the mark? It's loading. Now, the example I've given here, this is the value. Look at this value. We have column LA underscore code and data. So I've already created it here for you to see the real example. So if I run this one now, I'm creating a column, and here I'm doing data, let me say data value. Let me call it data value. So can you see example here? We have the value for LA code. We have the value, the first row, that's middle age that's 210. Second row, LA code as E1208, middle age as 890, LA code as D1009, middle age 1622. So if I run this one now, and you see it's gone through. Now, we want to pass in this inside this, just like I've shown in this PDF. Look at this PDF. I've shown something here. I said, we want to explore our RDD. It says spark context dot parallelize. This is RDD. Like I said, Apache Spark has got RDD and DataFrame. But in this example, based on what I've explained, we want to start from RDD and convert our RDD to DataFrame. And that's what we've done here. Say, how do we do that? We using TODF. So RDD dot TODF, we pass in the column that we have created, and we'll be able to show the results. So let's go back to what we have here. We have here, we have data value. This is our data that we're expecting. We need. Can you see? This is RDD. So let's run that. Let's go now. Now we have our RDDs. This RDD now, we have it here, and want to convert this our RDD to DF. So we want to convert it to DF, and we pass in the column. So when we pass in the column, we'll be able to run this. And now we can show our data. You see the result of our data now. And show is a sign that you use to show your results. You use it to show your results in DataFrame. So look at that. You see the name of the variable name. So we have RDD this, and this is the name. We now use this name, which is the DataFrame name. Dot show. Can you see the result? Now we can see the column name, the column, the keys, and we have the values in rows. This is row 1, row 2, row 3. Can you see? So this is an example of how we can convert our data from RDD to DataFrame. This is an example. That's what I try to explain here, that DataFrame can be constructed from different sources such as structured data file, tables in Hive, external databases, and existing RDD. For example, in terms of external databases, you can have a relational database. You can have DynamoDB, that's NoSQL database, and some other, MySQL and stuff. You can access all the files, but you can read all the files from there and use your DataFrame to transfer that transformation. So that's how it works. And you can even access other, data warehouse like Snowflakes and some other stuff. So let's go on with that. I've shown an example here. So our show is to print our result, to show our results, and we can see the example here. Now, in our data frame, there is something very, very important in data. You have to know the data you are getting in. You need to know the data type. That is first thing you have to work on when you are dealing with data. You need to understand this data. If I look at this data, look at this example, the example of this data, look at this one now. LA underscore name, LA underscore code, middle age. This one looks like, can someone tell me which data type is this? What does it look like?
String.
String, thank you. This is string because you can see it's got names. It can't be an integer. It can never be an integer. But this one, what can you say about it?
Basha.
It's an integer.
Okay, I think so. The person that said voucher is right because it's also string. But in the area of Spark is string. So now a string, because you know varchar is variable character. So this one is a variable character. So it's also string because it's an ID. It's just to identify, it's not a number. It's just to identify a particular person or a product or whatever based on what you've learned. So now this is a string. The data type is string. Look at this middle age. Is what? Look at
That's
this
an
middle.
integer.
That's an integer. Thank you. You can call it double integer, or long, depending on what you are dealing with. So here we have it as double integer or int. You can call it int. But if it's got 20917.123, what do you call that? If it's got the dots like say dot, let's say 578, what can you say about that?
Float.
Float, thank you so much. Because it's in decimal, it's got a decimal point. That is float. So that was what makes an integer different from float. So these are the things we have to take note in our data. And that is why you see, after constructing this, we are able to print the schema. We print our schema. And how do we check the data type? You see, for LA_code is showing what? String. For middle age is showing what? String. But do we expect this middle age to be string? Can someone answer that? No, we don't expect it to be string, because if you see from the data I've shown here, it should be what? An integer.
Integer.
So as a data engineer, you've seen this data is a string. That means you need to convert it back to what? Integer. Those are the things you have to take note of. You have to think that, okay, this data, first thing to check this data type using print schema, which is a function in Spark, using print schema. Then check the data type. After checking the data type, know what to do with the data after. So that is the aspect of converting data from RDD to DataFrame. And I've shown this. So this same data, we can also use our create data frame. You know, we use TODF here. We pass in the columns and we got the same result using this RDD. And we can also use create data frame. So we have our RDD. This is our RDD. We are still using the Spark module. We have spark.create data frame. We pass in the RDD, the same RDD here. The value that we pass in, you remember data value here. We're using the same thing here. So we pass in RDD here dot to data frame, like I said, and we pass in our column. So for us to grab all the column, use this asterisk columns, and you grab all the columns. Why we do that? Let's say, let me run it. So let's see the results. Now we want to show our results. If it's still the same, we have the same results as the same way we apply to DF, and we're using create data frame. And doing that, we can print our schema. Let's check our schema. Is it the same? The same. So can you see how we're using TODF and create data frame? Like I said, you can manually create data frame using TODF, and you can also use create data frame. And for you to access Spark, you use what? Spark from PySpark.SQL import Spark section. This is what you have to do first to run Spark. So let's go further. I've explained that part. So let's go further and deal with the rest. So I'm trying to combine two things concurrently to make sure that I explain with the PDF document and also do, hands-on along the way. But I will go back to the IDE so that we can do the same thing in our IDE, using our IDE. So now we've done this part now. I've shown you TODF. I've shown you create data frame. We've passed in this and we've got our results using our Google Colab. If we go further, okay, we've done this one too. We've done, okay, did we do this? Yeah, we did this. Create data frame. We use create data frame. We pass in our, okay, no, we have not done this. So in this aspect, instead of us passing RDD directly, we can also pass in our data and pass in the name of the column. That is what we're doing here. We're passing the data to create data frame, Spark dot create data frame. We pass in our data that we have to df, and we pass in our column, which is, let me show you here. So we can use this one, the same thing that we have, and do 1 second. Okay. So we have, let me use let me see, df equals to Spark data frame. We pass in our data. Remember our data here. This is what data, our own is data value. Data value. We pass in here instead of RDD. Then we do to df. We're still going to get the same result. If I run this one, it's going to give me the same result. We can do df.show. df.show, we see the same results. Can you see? And we can print our schema. Then df.print schema. Print schema. And that's it. We get the same, and we can check our data type. So this data type, part of our work is to check this data type and convert it to the correct data type. We have to take it back to the correct data type. And that brings us to importing some other library from PySpark, which is from PySpark.sql.types import struct type, struct feed. I will explain this: string type, integer type, float type. If you want to convert your data to float type, you use float. Let's say this one string now, let's say we have decimal point there. We can use float type to convert as a function, a module in PySpark, integer type, string type. So I'll go further to explain. I'll go back to our PDF. In our PDF, you will see that I said we can create data frame with schema. I said in this situation, you might need a common name along with their data type. You can create struct type schema first and include it when creating data frame. What this means is that, for example, look at this data. Let's say your real data is coming with no column name. Let me delete this. See deleting? Good. Can you see? Some data can come like this without any column name. Look at it. There is no column. Maybe as a data engineer, you are working with stakeholders, and stakeholders are saying, what do I mean by stakeholders? Stakeholders are people that, you're gathering requirements from. Reach out to them and they say, okay, please, we want this data, this is the data that we have. This is what we want to get out from the data. So this is where you interact with them and gather all the requirements and start transforming the data. Let's say, for example, stakeholders, they give you this data that, please, can you work on this particular data? Look at this data. This data hasn't got a column name. I've deleted it. Let's say this is how it comes. So you are expected to add a column name to this particular data when you are doing data transformation to process the data. So, and that's where we have this one. We have to now create a schema and pass in a schema. That's the name of the column name for that particular data that we want to add. We have to create a schema. That's the column names, all the column names, and the data type. We have to, from the beginning, determine the data type. If it's string, we have to make sure that it's correctly is string. If it's floats, we have to make sure we assign floats when we are using and creating the schema. And that is what this one is doing. So this is useful, especially when your data from CSV or any file does not come with columns. Can you see? I've shown you an example. Doesn't come with columns. I've deleted it. Let's say it's like this. So you can use this method to assign column name and choose data type for each column. Let's see an example. The example is here. Look, let's say we have, okay, we want to, for you to do that, in order to assign a column name, we have to import this library. Remember from PySpark module.sql.types, that's for data type. Remember, import struct type. Struct types helps you to assign your access other functions and be able to assign the column name and the data type. We have struct field. Can you see field to pass in the name of the column? And we have string type. We have string type, we have integer type, and we have float type. So let's go further. Let's run this one now. If we run this one now, we can now access anything related to struct type, struct field, string type, integer type, and float type. Then we can now look at this one now. We can now look at this value now. In this case, I'm running this value. I'm running it like we have our CSV file, like our normal values. Here is like values. There is no column name there. Values, in rows. So there is no column name. So here we've created the values. Then we now create our struct type. Passing the name struct type from here. Can you see the struct type? Inside this struct type, we need to create the column name string. We now have a struct feed. Can you see? Please take note of this. Can you remember this struct type, struct feed, string type. So we have struct type, we have struct feed, and we pass in the column that we need. And what are we expecting from this? This is an ID. We expect it to be string type. We put string type and we say, okay, we want this string type to be true. That means assign this particular, this column, assign it as string, as a data type, true. Assign it as string and make it true. That means don't change it. Then we do another one. We have struct feed. Can you see how you're applying struct feed now? Can you see this square bracket? We have struct feed again. Our next column name for this 210. Middle age. Middle age is an integer. So we have integer type, true. Let it be integer. We go further. We have our third column. We have low. Low is a string. We now do struct field and we assign it level. I'm giving it a name. String type and equals to true. So when we run this one, when we run it, then we've been able to create our schema. We've created our schema here. So let me call it schema. This is our schema. We want to assign a column name. So that's schema. So now this schema, we can go down to our Spark module. We have spark.createDataFrame, like I said the other time. Here you can access your data and pass in this data value here. Comma. What's the schema that we're expecting? We've created this schema, which is schema. Let me change the value schema. So I change it to schema. I can decide to do schema underscore value, so that you can see schema underscore value. So now we have schema underscore value and we have this. So we can run this one now. So these particular values that we have created, we are treating this like our CSV file that is coming without column. But we have created the data type here that you should assign this data type to it. So when we pass in this one, the schema, then our value, when we run it, then we can access this particular data. And when we run it, can you see it has assigned it the column name, the middle age, and level has assigned column age and column name, that's LA underscore code, middle age, and level. And here we can print the schema of our data. You will see it's now in a correct expected data type we are the data type we are expecting. Look, we're expecting, we added string here. It's coming as string. We added integer here. It's coming as integer. We added string type here. It's coming as, can you see? Level is string, this one and this. So in this kind of data, we have decided to create our schema ourselves and assign it to the proper, each values, the columns, to the proper data type. So that is an example of a data with no schema. So let's go to our IDE and maybe do one or two things, and we can do the same thing there. I just want to, let's explore our IDE. So we have this data. Okay, we have this data. Let me, 1 seconds. Okay. Let me run this. Okay, last time we used this. Okay, so let me run of 1 second. we want to create a Python file. Let me say DataFrame .py. That is Python file, to create a Python file. So saying hard. So from PySpark, let me see. I think I've not imported .sql imports Spark section. Is it coming? No, the library is not coming. So that means not being imported. So let's see what we can do here. Settings, go to our interpreter. I can go here and run PySpark. So I'll do this one. We can also do, this is going on. Okay, so it's going on. Okay, so it's successfully installed. So let me do okay. See, it's not, can you see it's accepting that? It's saying that. So here we have data. Let me, okay, I'm inside here. So let me do pip install PySpark. It's done already, but I want to run it again. Okay. Okay, so can you see requirement already satisfied? So here I can do Spark equals to Spark section, dot builder dot app name. That's open data. Keep using your name, data engineer dot, oh sorry, dot get or create. Can you see? So we can now do whatever we want to do. Let's say, for example, we want to read this file. Let me get the part of the file. This is the part of the file. So I can do DataFrame equals to Spark dot read dot format. Format is we expect it to be CSV. So just want to read this file for you that you know that it's working. Then we can try it on our own. CSV dot load. Then we can load the file part of the CSV. This is our CSV, and it's going to come with from my local parts // so let's see if it's going to work. Then this. So let me run this, which is the second. Is it DataFrame.api? Okay, give me 1 second. Let me save this. Okay, sorry. Save all. We have settings. 1 second, please. Okay. Okay. So just gonna use this one, data frame. I'm gonna use this one temporarily. Okay, so let me run this one now. It's showing me error. Okay, showing me an error somewhere. Program or by okay. Okay, let me just cover this. Let's go back to our 1 second, please. Okay, go ahead. Okay. So it's giving error somewhere, or the Spark section, something is running perfectly. It's running. So let me do print df here. So let's print df. It's still giving me error. Spark session.builder.app name. Better create Spark session, create Spark config. Let me see where the error is coming from. Print data frame. Okay. Okay. Okay, still giving me error. So why later I can sort that particular part out, fix that one. But let's continue with our task. So now, so we've created our schema data type. We understand how to create our data type. We've gotten these results. We've gotten the data type. We have the level string, we have integer type, and we've got the rest. So let's say in the case of no header, we want to use our proper CSV file now. Let's say CSV file. It's going to take some time, but let me just try it. So we have CSV file. Our normal CSV file with no header. We want to use that. Let me see if I can put that one here. Okay, so now let's say no schema CSV. In that case, we can run this. Sorry, give me 1 second. Let me get this environment ready. I think it's very important. And that we can explore wherever we want to do better. Seconds. Okay. 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 Circumspace. Okay. Okay. Let's just keep using this part. So we have this upload file. Let's say we have no want to upload a file without a column name. So let me try from here. I'm going to import no schema file. Let me see if I've got it. No schema, seconds. I've deleted this particular file, so I'll save it. Let me save this one as UK data download. Yes, that's a good idea. So let me go here. I'm going to use this environment for now. Still going to do the same thing, UK data download. So let me see. Okay, 100% done. Good. Now we're going to use this particular file here, and the file is ukdata.csv. Remember, this file, I've deleted the, download. Where's the download? Can you see? I've deleted the column name from this particular data. So we're going to use this particular data. We've got how many column? 1, 2, 3, 4, 5, 6. So we want to create our own column for that particular data. So how do we do that? The name is UK data. So I can go here and pass in the name of the file, ukdata.csv. Remember our Spark. Let me call this one DataFrame. DF, the variable name is DF. We have Spark.read.format. What's our format? We have CSV. Can you see the name? .csv. If it's JSON file, you put .json, you put JSON file here. JSON file. If it's package file, we have different file. Package file, sorry. Package file. This is package file. So we have, different files, XML or stuff. So it can read anyone. So in this our case, we have it as CSV. That's the CSV file. Option.header. What we are trying to do here is we want to say, okay, this particular data, can you assign an header to it and make it true? The schema, remember the schema that has been created here. How many schema do we have? In case of our data, we have how many column name, sorry. Column name we have as 1, 2, 3, 4, 5, 6. So we can call this one maybe in this case is a string. This is a string. This is an integer. So let's follow that pattern and get something done with that. So we have the first one. Let's call it country name, country_name. I'm getting it down here. Second one, let's call it country ID _ID. The third one, we say middle age, just like we have before, middle age. Then we have the next one, adults. Let's say adult. I'm just calling it any, giving it any adult age. Then third one, let's say elderly. So we have how many? 3. Then we have the last one. We have 10. So teens. So now we know this one is what should be what? String. This one should be what? String, because it's an ID. Just like what we did the other time. We have this one as integer. And this one we have it as integer. We have this one as integer. So it's like you're counting something. We have integer. Good. So we have this. So now let's try and pass what we have here. Now in our struct type, like I showed the other time, we have struct type, we have struct feed. In this case of flight name, we are going to have our first column to be country name. I'll copy this one and put it here. Struct feed, a struct type, struct feed, we have country name. Then we need it to be string, like we stated here. Where is it? Here, we said the string. The next one is country ID. Our country ID should be what? String also. So we change this name here. Sorry, 1 second. this one as country ID. It's string. So the next one, it should be integer, which is middle age.
So why do we have the true written after each one of them?
Each one is that when you assign this integer type, identify it as true. That means it's integer type. It's not going to change. Does that make sense?
Okay, so what other options could there be? And why would we have such options?
If you remove true and you put false, it can just give it any particular data type and say, okay, this integer type is not compulsory for it to be true. If it's false, automatically when you print the schema, it can assign it as string type.
How about say if you don't input anything there, what happens?
You have to put something
If
there.
you don't put true, you have to put something there.
Yes.
All right.
You always
Okay.
have to put something there. Can you see? I'm assigning true for it to show that, okay, this is the column name, and we want you to create a data type integer type, as I've mentioned here. You see, I was trying to arrange it as middle age should be integer, adult age integer, elderly integer, teens integer. So that I'm following this particular pattern. So we've reached middle age, which is integer. Our next one is adult age, elderly, and teen. So they are all integers. So we can go back here and say this is middle age. Let me put underscore age there. We have the adult age. Then we can create the last one, which is string. We don't have enough something, so we can do comma. We're going to do struct feed. Don't forget, can you see? It's giving you what is expecting. Struct feed, then open bracket, and then what's the name? Teens. That's what we're expecting. Our teens, then we have comma. And what type? Is still integer type. Integer type. Can you see? It's suggesting the type for you. So we have integer type. And what should we make it true? Yes, we are assigning integer type. Don't change it. That's it. And we can run this. Can you see? We've run that. So now you remember we've loaded our...
Sorry, sir. On the adult age, is it string type or is it integer?
Integer.
Adult age.
Adult
Integer.
age. Oh, sorry. Thank you. Thank you. So it should be integer type. Thank you so much. Because you've already said, okay, from the data we are expecting is what? Is integer. So we can assign integer type. Good. Thank you so much. So we have struct. This one is string, and the other one is string. Country name is string. Country ID is string. Struct feed middle age is integer type. Struct feed adult age. Adult age is what? Integer type. And teen is what? Integer type. So we will run this one now. Already we have our data here, so I can highlight this one and comment it out so that it will not be running again. When you comment something out, you don't need to run it again because we've already loaded the data here. The data is here. So now, let's run this now. You see, we've set our UK data. Now we have spark.read.format CSV option header equals to true. Our schema, what's the name of our schema? The schema is here. That is what we've created here. Let's see. Schema spark. Schema spark. Or I can decide to change it to schema data. Schema data. So let's say schema data, then I'll change this name to what? Schema data. Passing here, data. Then we are loading our CSV. What's our CSV? Yeah, our CSV name is what? ukdata.csv. We pass in our UK data.csv, so we can run this one now. When we run it, and we can show. So we have UK data.csv. Let's show our result. We call it DataFrame. So we can so DataFrame.show. Then let's see if our schema has been assigned. Can you see the column name? Can you see it's been assigned? Remember, this is the same data that I used. We deleted the column name. So I give it an example. I now uploaded it here. I pass in the struct type that we created here, and we're able to get our proper column name. So we have column name country country days, country ID, middle age, adult age, teens. And if we want to print the schema, we can print the schema and see if we are getting the right column. Can you see? String, string, integer, integer, integer. Are you getting it now? Please, if you have any question, you can ask before we continue. Any question? Okay.
Now that we got 5 there, this shall I think we had 6.
Where?
We need to add the last one there, I think.
Which one?
You got 1, 2, 3, 4, 5, right? Columns.
This one.
But yeah, when we were doing initially, we had 6, right?
No, it can't be 6. It should be 5. Is it 6?
It should be 6, I think.
Okay, let's check again. 1, 2, 3, 4, 5. Is it 6? Okay, let's see.
Yeah.
1, 2, 3, 4, 5. 6. Okay, let's see. Which one are we missing? Elderly. Elderly. Are we missing elderly? Okay. Okay, let's check. I think there is a mistake. So it's capturing only.
Quick one. Yeah. So since you did not assign any column for the 6th one, so that the data did not pull into the data frame then.
Thank you so much. That's what is happening. Let's check. Let's check the last one.
Okay, didn't pull in. Okay.
Exactly. Let's take the last one. So we have Darlington. We have 28245. Is it grabbing it? It's not grabbing it. Let's say County Durham. It should be County Durham, which is 93168. Let's check. County Durham 93168. Should be County. Let's check our County Durham. County Durham. Sorry, 1 second.
It's at the top. There's the second line.
Oh, good. So can you see it's not grabbing it because we didn't assign it? So let's go and assign it. So it's stopping here, 93168. Thank you. That's a very good observation. Can you see now that you can see after it's following each columns and it's assigning. So the one that is not assigned is not being assigned a particular data, column name is being dropped. That's a very, can you see that's another observation? Thank you now. So now let's go back to here. So we need to assign our our adult, elderly before teens. Good. So I can go back here and do comma struct feed, our struct feed again. Then we have elderly. Sorry, 1 second. So we have elderly. Then elderly we can now do, we expect it to be integer type. Integer type. We pass in our integer, and what are we expecting again? Comma 2. So we have another comma here to separate it. So let's run this again. And we'll be able to capture that. Good. So let's run this again. Now we have our full data frame. Our full data frame. So let's print our schema. Then we have our schema printed. So it's now including our elderly. Can you see? So we have, this is how you can pass in the column name and also assign the data type from the beginning as you are extracting, as you are reading your data. You know, here we are reading our data from here. We quickly pass in CSV. And as the data is coming, which is this UK.csv, let's say for example, if the data is from S3 bucket, you have an S3 part here, S3 part in the cloud. So you have S3 part here, just like, let me give an example here. I think it's better if I show an example here quickly. Okay, so Amazon. 1 second. Okay, so let's say this S3 part. Now, this is this pocket. We have a file here. Let's say this file. Okay, I don't want to see this or no. Okay, this is the UK data. So this UK data, we can copy this URL parts. Can you see S3 URL parts? And use it. Let's say is should be here. Can you see? Can you see the data now? You're accessing the CSV file from S3. So here, if I have access to this S3 directly, if I run it, it's going to load the same data. Can you see how you can work on the cloud now? So I exploit this particular S3 CSV file and passing. You know, I went to my Amazon account S3 bucket. So I tried to show you an example how you can deal with the same data using your S3 if it's S3 part. So in this case, we are getting it from our local environment, which is Google Colab, and we're using this part. So when we run it, we got the same results, and this we're able to print our schema, and we got our schema. So let's go on with what we are doing. So we've done create data frame with schema, and we've been able to do no schema. We've done this part. We're passing the schema here using struct type, struct feed. We set this true, and we got that. And we also used normal file. Can you see? From file, we use our normal file now. So, and we got the same answer, the same result. Can you see no header? Here I said no header, just like we did. And I got this particular stuff. But in the case that let's see how we can see the header itself. If an header is not assigned, let's say DFF, I'll call it DFF. Let me remove this part. You will see it's not going to show header now. Sorry. DFF now. Let me use DFF. Can you see we didn't assign header there? So let's see the results. Can you see? Without header, it's going to get a default column name for us. And it's going to assign this to it. And that's what you see here in this aspect. C0, C1, C2. In case you use .load directly, if the file does not have a schema. So it's going to give you a default schema, which is going to be like this. It's going to give you a default schema in this format. So now, I've shown how to pass in the schema, and here, that's what we did here. So let me go back to what we've done before here so that we can revert it back. We have df, sorry, wait a second. Okay. Okay, we have this one as df also. So we are returning back to our normal something after assigning our schema. So we've gotten that, and that's it. So we've reached this particular stage. And there's something very important also to explain that I need to explain. You know, I was talking about distributing job, you know, assigning your task and making sure your work is done, you know, effectively. And that brings us to this getting number of partitions in DataFrame. We've been talking about talking about DataFrame, talking about cluster manager, node, and stuff. So like you have a worker, and explain you have a manager, it's got like 5 workers under him or her. And they have 5, let's say we have a task to be done. If one person do the job, the person will do it in 5 hours. But the duty of the manager is to assign that 5 hours job to 5 people automatically and get it done within few seconds. And that is what this particular part is doing. So DataFrame, in DataFrame, you can determine how you want your file to be processed or to be written to destination. Let's say, for example, that's S3 part I showed you. You want to write the file to S3 in the cloud, or you want to write it in the local environment. as a path. You can use this RDD. You can use df, this data frame that we have created, and do RDD dot, this is a function RDD dot get num partition. You can determine your number of partition by using this particular function. It will read it for you. It will tell you if it's going to be assigned 3 files, 3 different files. For example, we have this CSV file now. If you want to divide it into 3 files, so one part of the file will come like this, the other part will come with another row, the other part will come with another row. So you can use this number of partition to assign it. But to determine by default the number of files that's going to come, just use df.rdd.get num partition. You see an example here. Let me show you. So here we have data frame. Our something is data frame, not cap schema. We have data frame. Let's run it. We want to know the number of partitions that this file is going to come with. How many? 1. That means it's a whole file. It's not being divided. So Spark can do the job just, with one cluster, with one node. You understand? Assuming that we've got a very big file, Spark will look at it and assign it and divide it maybe in 3 places. So one thing about this, okay, now I've shown you that. Let's say, for example, we want to repartition this particular file. Okay, we don't need to repartition because it's showing 1. Okay, let's say we want to repartition. Yes, we can repartition. Look at this. For us to repartition, we can just use df equals to df.repartition. Let's try it now. This file is coming as 1. So let's say we want to repartition this file. We can do df.repartition. We want to divide it into 3. Let's put 3 now. You will see what I'm trying to say now. Repartition. So if I run this repartition, so seeing this, so let's go back and check our df repartition again. If it's still going to give us the same thing, you will see our value. Okay, it's still giving us 1. I think there is an issue somewhere. Oh, sorry, there is an, oh, it's correct. Okay, that's correct. Okay. Coming. Okay, still giving us 1. Okay. Try to. Okay, still giving us 1. Well, anyway, this is the repartition part. Maybe if I have another file along the way, I will show you how it's going to give us this result. But in this case, it's taking us back to 1. So this repartition, what it does is that it helps you to split your files into, let's say, 3 different files, 4 different files, depending. But by default, it's going to do it without assigning repartition. Spark is going to divide the job and assign the task and maybe create like different files. That's what Spark does. So, but to get the number of partitions that the Spark is dividing it into, you use df, that's the data frame here. That was our data frame here. Df, that's the file name, data frame, dot RDD, this is a function, dot, inside this RDD, you get num partition. Get num, can you see it's SC dot parallelize. SC is Spark context dot parallelize. So it's an RDD function. But you still need to exploit when you want to check the number of partition. And you can use to repartition your data, you use repartition. And we've got other one, which is this. So coalesce is used to reduce the number of partitions in an efficient way. For example, let's say your data is coming in as 3 different files. So you can use this coalesce to put the file together as 1. So if you see a coalesce is used to reduce the number of partition in an efficient way, it's an improved version of repartition. So it helps you, instead of having your file as 3 different files, let's say this is 1 CSV, 2nd CSV, 3rd CSV. Instead, it's not going to allow you to divide you assign these colors, and it's going to group them together and give you, as in this case, if it's 2, it's going to give you as 2 different files instead of 3. Let's say by default, Spark should give you as 3, but if you assign this value, it will give you as 2. If you put 1 here, it's going to come out as a full CSV, just one CSV file. And that is that aspect. Do we have any question? Any question?
Not for now, sir.
But is it clear?
It's becoming clearer when I get on PySpark and I start doing it. If there are challenges, then I can refer to you.
Okay. Lee, Jerry, do you have any question?
Yeah, still clear for me now.
Still clear. Bola, Damilola.
Yeah, it's coming along.
It's
step
making
by step.
sense. It's making
Yes.
sense.
Yeah.
Okay, that's good. Now we go to function. Please, let me give you very honest advice. All these things, I don't know, some of you, maybe you started working as analysts already. So you will know more about what I'm trying to say. You know, all those stuff we've been talking about, we've been teaching, SQL, Spark, we'll be treating some other stuff. They are actually enough for you to get job. In fact, only Spark itself, even SQL is enough. Now imagine you have SQL, Power BI, you have Spark. That means you've got everything that you need to undo any projects. To be honest with you, all I just want you to do is to nail this, all these things that we have been teaching. If you know what we are teaching, I'm telling you, when you do interview, you'll be fine. To be honest with you, all you just need is, please just go through it. By the time you get just like, wow, I've done this part. Oh, I've done this. You'll be wondering, you'll be saying, so wow, we've gone a long way. And there's some other aspects we're going to cover, which is, the stack itself, infrastructure for AWS, how to create that infrastructure. And that comes to, how we created, you see the S3 bucket that I opened the other time. We're going to be creating the stack itself to create this S3 bucket, to create everything. So there is nothing you need as a data engineer or a cloud data engineer. You can work as a cloud data engineer. You can work as a data engineer. In fact, with the Power BI, everything, you've got everything. If those things are included in your CV and you're able to practice, trust me, you'll be fine. All I just wish you can just take it so serious, please. That's my honest advice. So I've seen a project where all I did all throughout the project, should I tell you, I was only doing Spark. I was assigned to transform very huge amount of data. And we're going to touch everything. I was assigned to work on very huge amount of data, where I was working with other software developers and a business analyst, you see. And all I was doing was working on Spark, using all these functions, all those things I'm showing you, and those are the things I was doing. So please, I will advise you, just take it so serious. Don't sit as if, it's just a lecture. No, it is not a lecture. If you know only one out of this, seriously, by the time you get the job, you just throw your CV again. Within a few seconds, you get like 10 jobs. Let me give you, let me tell you about, at a point, I wanted to change my job at a particular point, and I just said, but it's not necessary. Not that I want to change. I didn't plan to change because I was okay. And I just said, oh, let me just see how the market is. And I just, uploaded my CV, and within 1 week, I got 5 offers. Is it 5 or 6? I think almost 6 offers. 6 offers all together. And I was like, and I rejected all of them. You see, I rejected all of them because I was okay where I was then. I was like, oh, okay, so this is how the market is. Oh, interesting, I just played, and one of them was calling me that, oh, do you know what? We're going to give you shares. We're going to give you this. Don't worry, please. And they were begging me, we are ready to increase the amount, can we negotiate? I was like, no, So I'm telling you how powerful what we are teaching is. Please take it so serious. I can bet it with you, with what we have touched, you've known, in fact, you've known beyond, you've known so much, seriously, with SQL, with Spark, and with the SQL, you can even use Spark SQL library, using the same SQL you've learned. You can work on lots of things, and the rest. So that's why we say, please take it so serious. Just keep practicing. To be honest with you, you'll be fine. You might not know the value of what's. I know you paid for this. You know that you are going to gain something, a value for your money. But please forget about us. Just focus on, after teaching you, please go and watch the video again. Do it, make mistake, go back again, make error, send the message to us, then we'll fix it. Then we'll go through it together. So that's my advice, please. So let's go on. We have another aspect. In Spark, we've got several functions. Some of you are familiar with some of the functions that we have here. We have select, we have with columns, and we have with column renames. So this function, like our SQL, we have select. We've been using select. So it's still the same thing as select in SQL. All programming languages they are more or less the same. They do something similar, but the way they do it is just, some of the transformation you do in PySpark, you can use SQL to do that. There are some projects that you'll be focusing on data engineering with SQL only. And some, if it comes to maybe dealing with large amount of data, you might be using Spark. So it's still work of a data engineer. And also you use Spark for machine learning and Spark streaming. You use the same, in Spark streaming, you use the same function. The way we are doing with column rename, you read, the only thing is that when you are reading your file, you read stream, not read.csv, you read stream in Spark streaming. So you can deal with data like Kafka, a JSON file in streaming, all sorts of things. So this is Spark is a very big, module that can do lots of things. So we have select. Sorry, excuse me. We have select function. So it's used to select single multiple column by index. So select is a transformation function that helps returning new data frame with column of interest. I'm going to show you that. We have to, with column. With column is a data and is a transformation function of data frame using changing values, converting existing data type of a column to a new one, creating new column, so on. With column rename, this with column can be used to change your data type. You can use it to do aggregation. You create a new column where you are doing aggregation. Aggregation is you are doing multiplication. Maybe you want to subtract two columns from each other, or you want to multiply, or you want to add two columns together to give you new value. You can use with column to do that. You can use it to create a new column name also. You can use it to extract a particular, maybe a substring from your data. Substring is, let me give you an example of substring here. Substring is like, let's say, Darlington now. You want to create dal only. You use a substring to extract that. You have dal here. Here you have can't. Sort of things, all sorts of things. You can do that. With PySpark also, you can do pivoting of data. A lot of time you'll be working on pivoting. pivoting of data, depending on data you are transforming, some data comes with date, and you have to pivot them and create a date column where they can, when you are working on Power BI, they can maybe customer or users, should I say service user, can filter on the Power BI to find some details about, some data, So that's what I would say. So we have with column rename. So it's a transformation function of DataFrame used in renaming on multiple columns or all columns. So you can use it to rename all columns. You can use it to change the name of existing column to new name. So for example, this is the function with column rename. We have existing to new name. We have another one called filter. Filter is used for filtering the rows from RDD, can you see, DataFrame, based on condition, filter. Let's say, for example, you want to set a condition for a particular, look at this particular data that we treated. This particular one, you want to set a condition that you want to filter age that is greater than 96150 and less than 96110 and greater than 27436. You can do that with filter. You can use the filter to do that. We'll show an example. You see an example in filter. So now we have that, and we have counts. So counts that we all know is that you are counting something. You want to know the numbers. You remember the count that you use in SQL is the same thing. Even filter. If you see in the SQL you use where, you remember where you use where when Uncle Yinka was explaining where how something is greater than, it's still the same thing as filter. You're filtering. You are filtering based on condition. Counts is you are doing the counts. Distinct, good. Now we'll go to distinct and drop duplicate. Distinct is very good when it comes to when you have a huge amount of data and maybe there is a duplicate in your data. You use a distinct. You apply distinct on that data to drop all the duplicates in the rows. It checks through all the columns and across the rows, and it drops all the duplicates. And this helps in efficiency of your of the application you are developing. It improves performance. Imagine you have 1 million data that has got duplicates. That will cause redundancy and will reduce performance of the service to customer. But if you are able, as a data engineer, you'll be able to discover that, okay, this data, let me apply distinct or drop duplicate. It takes off the duplicate, like 1 million duplicates out of almost 500,000 data. No, sorry, out of 1.5 million rows of data. We have 1 million that is duplicate. If you apply this duplicate, the data will drop to 500,000. Imagine, that's a very good one. So it increases the performance and efficiency of the system. And those are the things you have to focus on when you are doing data transformation, because every company wants a service that is very, very fast. They don't want service that is very slow. Maybe in data transformation, you want to transform data and it's taking like 5 minutes to see the results. That's crazy. But with drop duplicate, you'll be able to filter out all those noise. They call them noise. It prevents any form of redundancy, to ensure a quality data. So how do you ensure quality data? By checking all the data after transformation, dropping, the duplicate rows, and in order to increase the efficiency and performance of the, of the system. So those are the things, in interviews they can ask, and you'll be able to answer that way. And we have distinct drop duplicate. We have sort. Sort is you are sorting data in ascending order or descending order. If it's in alphabet, you sort by A, B, C, D to Z. If it's descending, you start from Z, Y. That's what this one is doing. We have order by. You can order by. And you can also do group by. In group by, we do more of, you use group by for aggregation operations like count, mean, media, sum, average, which you have seen in your SQL. So it's similar. Can you see they are all working the same way? The only thing is the way they do stuff might be different, maybe different there. So that is that aspect. Okay, so now let's go on. I've talked about the functions now. I've explained all the functions. So I will now start showing example of the functions that we'll be using. So here I'll just talk a bit. We won't be able to focus, we won't say much about, I will just touch a few things about all the functions. So let me see if I have a few things to add here. 1 second. Okay, we touch this. 1 second. Oh, okay. Let me show you an example of writing this file to a CSV file. I think that's a very good one. We have our data frame here. Get non-partition. We can write this file, this data frame, to a local environment, the one that we've assigned. So the name of the file is going to be CSV. Let's run it. Can you see? Let's see. Can you see data engineering? Can you see the file? This is the file. Can you see the file? Can you see the name? So this is the file. I can decide to, sorry. Oh, sorry. Okay, that was no problem. So I can decide to download this file now. Can you see? Let's open the file now that we have assigned. And you see, that's how you write file to destination. Can you see now? Can you see the name? Can you see the file? So for example, you want to write it to S3 bucket, you just use that part also. You put that part where you want to write it to S3, just like I did the other time. S3, okay. So that's it. So that's the file. Now we can see the details of the file. I've downloaded it and I've shown you an example. Here, with no column name, but here, after we did our transformation, we've got a column name. Is that clear? Hello?
Yes.
Okay, good.
Come again, sir.
I said, you remember here we loaded this file with no column and we pass in the schema, you remember? And this is our output with column name. Is that clear?
Yeah.
Okay. I mean, this particular one that we did. Okay. This particular one, remember the one that we did here after passing the column. So I'm writing it, I'm writing it to a particular part now. I now use write. You remember, see, look, you use df.write. This is a function. The option, do you want the either to be assigned? Then CSV. So if I take this off now, let me say header equals to false. Let's see what's going on. Some things that I always use header equals to true. Can you see it's saying already exists? So let's manipulate it. Engineer. Data engineer. So let's see the file. Can you see it's created? So this is the file sources. Let's see if it's got header. I'm not sure it's going to get header because we assign as false. Can you see? In that case, we assign it as what? False. Because we assign it as false here, what did we get? No header, because we assign it as well. The same thing applies to if you say integer type is equal to false, it's not going to give that name. Is that clear? So that is that. Do we have any question? Any question at all?